The next system is a package. You see, package, like you see, dictable split, what we consider as a bigger version of split. No? Similarly, this package you can consider as a bigger version of window. Just for comparing, just for learning point of view, window is a very small unit, but package is beyond having the capacity beyond the capacity of window. Window, you can find this 0.5, so to say 2 TR. But if you talk about the package, start with the 3 TR, commonly available up to 125 TR, and it can be available up to 360 TR, depend on the location and the make. If you talk about, say, in Saudi Zamil, you can find up to 360 TR. But most of the manufacturers, they're offering this package in between, means starting from 3 TR up to 125 TR. And this range may vary from make to make and from location to location. So what I'm trying to explain is, if you're comparing this with a window, just I'm comparing as per the technology, not as per the capacity. Capacity point of view, it's a very big unit. Package, why I'm calling as a bigger version of window, because in window all the components, all the the major components you'll find in one unit. Na? Similarly in package also, all these four components in one unit. In that sense, you can compare, but rest of the thing is different. So let me give you the idea first, the concept. In the image, you'll get some idea. And at present on screen, this is called air cooled package. You will find water cooled package also in Blue Star or in few makes, not commonly used. In India, you'll find this water cooled package in Blue Star or in few locations, but most commonly in Gulf or in many locations, package is commonly available as air cooled. And the difference between air cooled and water cooled system. At the time, at the time of vapor compression cycle, we discussed this point. If the condenser is cooled by air, that this system can be a package or can be a chill water system. That we'll discuss next. Next means after completing the VRF and other systems. So if condenser is cooled by air, that system we can call air cooled system. So here in package, you see, first of all, the components: compressor, condenser. This we can consider as one section. This second section, you'll find evaporator and this fan motor and a blower. And you'll find the expansion also. Expansion, you'll find it can be in section 1 or section 2, because we are not bothered about the noise now, because this complete unit is placing outside the building. In case of split, this expansion you'll find in outdoor to reduce the hissing noise in the indoor. But in this case, depend on the model, it can be on this side or this side. So this 4 components in one with the 2 separate section. And remember this section 2 with the double skin. And double skin term you'll find in the specification. Double skin refers to insulation body with the insulation. Means here you'll find the insulation. And why insulation is required? Because you'll find the cooling effect on the evaporative coil. No? On this side, we don't require insulation because we are interested to reject the heat. You'll find the fan on the top, so the air will suck from outside and through. So we are interested to reject the heat. But this side insulation is required to avoid the loss of the energy, means loss of cooling. Okay, so in package at evaporator side, you'll find double skin, nothing but a cabinet, then insulation, again inside one more cabinet. Okay, and here in this image, you can find, you see,
Double
this
skin
skin,
means the both the
double
side.
skin means insulated body with the insulation.
Okay.
Okay, you'll find a cabinet, then insulation, then one more cabinet inside, or a cabinet with insulation. Inside you'll find a thermocol or a polyurethane completely in the site. So generally we used to call double skin. So remember the term double skin means body with the insulation. Okay, it can be with the different units also. So on the right side image, since it's a air cooled, you see this fan is used to cool the what? Condenser, this side. Okay, so this side is a condenser side, high side, and this side is a low side. In that you'll find the evaporative coil and a fan. And this is, we can call as a supply duct, and this we can call as a return duct. And how you can identify this? Remember, supply duct compared to the return duct is smaller in size. Why? We'll discuss that the time of duct sizing. Just for identification, this size is bigger than this now, or else any at this level, ignore this. You can consider one as supply, one as return. This is used to supply the air to the conditioner space, and this is return from the conditioner space. And in between, we can provide the fresh air also. Okay, so the first point, this is a bigger version of window. Second point, we can attach the duct. I'm talking about air-cooled system. Water-cooled we'll discuss next. Let me complete the air-cooled. You see, second point, we can attach the duct. In that, we required a supply duct as well as a return duct. In the previous case, return duct was optional. Let me show you. You see, in this case, there is no return duct. This is called free return because in all the cases, we don't require the return duct. So what will happen in this case? This complete area above the false ceiling, we used to call return air plenum. And this is called free return. Anyhow, this suction is above the false ceiling. But if I place this complete unit outside, means return is required from the space where you are supplying. Okay, so for air cooled package, remember return air duct is required. If you not use the return duct, what will happen? The suction of the complete outside air, na? And outside air is hot and humid in summer. So that will directly increase the load on the cooling coil. And you know the fresh air is hot and humid. And if you completely use the fresh air without return air, what will happen? The load on the cooling coil is going to be more than double, because remember the heat gain through ventilation also one of the major source of heat gain in summer, in winter also for heating system, but at this level I'm talking about the cooling system. So return is required. How exactly? I'll show you the drawing also. But you see, just this duct is entering, say vertical duct, then again it will enter in the floor. In the floor, it will connect to the A terminals like a previous ductable split. And above the false ceiling, you'll find the return duct, and the air is this. With the return duct, we can use this. And you see, we can add a opening here with a damper to introduce what? The fresh air. I'll show you in the drawing the detail about this. So we can provide the fresh air also as per the requirement. We can provide the duct for uniform distribution of air. We can provide the fresh air and the capacity. We can use this for complete floor, for multiple spaces, or for a complete villa, or for a complete building. Building means like G+3, G+4, etc. Depend on, and I'm not talking about high-rise building. Okay, so this is simple concept for what? Air-cooled package. We have some more points to discuss. You see what I explained? It can be considered as a bigger version of window, and the capacity beyond the capacity, and we can attach the duct with the ventilation. Typical available in starting from 3 tier up to 125 tier, and in market you'll find 360 or 400, more than that, depends on the make and model. In general, for entry point of view, you can use this option. Now if you talk about the types of package, what I explained just now is air cooled. Why air cooled? Because this condensing unit is cooled by air. But next we have a water cool also, but let me complete this air cool first. You see, this is a detail for air cool, the same components. You see, this is for supply duct, which can supply to a complete floor or can be a multiple floors. And this is a return from the space. In the drawing, I'll show you one more image. If you have confusion, you'll get the clear idea. Apart from this, you'll find all these components, what I explained: compressor, condenser, expansion, evaporator, everything in one unit. For entry point of view, this is air cooled because this condenser unit is cooled by air. That's it. This is a major difference between air cooled and water cooled package. Okay, so I'll explain water cooled. Let me complete this air cooled. Here I'm showing one. Let me show you one drawing. I add one image also to understand the concept. You see, here in this is air cooled package. You can consider this as a supply duct, and this is return. You see, supplying the air to this, say, first floor, supplying the air to the ground. At the back side, this duct is continuing, and it is supplying the air even to this ground floor. And you see return from the ground floor is here. Like supply, we don't require complete return duct. One opening is enough because you see this complete air is going to suck. Or else we can go for one more opening here. And all this we can collect with the bell mouth opening. I'll show you bell mouth opening in the drawing. Then you see this complete return from ground floor, return from this first floor and supplying back to the unit. In between, we can introduce the fresh air as per the requirement, as per the calculation. How much opening is required for fresh air that you need to calculate, and that much opening we can add here at the return with the VCD. The same you'll find in the drawing. Now try to understand this in the drawing. You see, here is a small villa of G+1, and you see on the roof, one package is installed. RTPU, rooftop package unit, F1, and here F1 is, this is for first floor, and you see this is supplying the air to the ground floor. Okay, so we'll verify for one, say first floor. This package you can find, you see, this magenta color is a supply duct, and this yellow color is a return duct. Okay, and how I can say it's a supply, most standard point of view, this cross means supply, one diagonal line means return. You'll find all this at the time of ducting, just I'm giving the preview. So you see the duct, this is placed on the roof now, and this duct is running, and here this is a shaft, means a building, this OTS or a shaft means vertical. And this duct you can find, it will enter in the first floor. This left side is a first floor. You can find, you see, in the first floor, this duct is entering in the first floor after the vertical duct and supplying the air to the complete first floor. And if you talk about return, you see, return is only a piece of duct. This is called bell mouth. We are not running the return like supply na, because above the false ceiling complete area we can consider as a single zone. And this is a return duct, and this return duct again to this floor. And now you can find opening FAD, fresh air duct, you see, with the VCD. So we'll go for we are connecting the fresh air duct with the VCD like a valve. So normally it's open so that the fresh air will introduce with the return air. So fresh air and return air mix and supply back to the rooftop package unit at the evaporator side only. The condenser side is totally separate from this ducts. It will not connect to that because condenser means is used to suck the air from outside and throw outside only to and picking the heat from the condenser. This two duct, it will connect at the evaporator side. One is supply, one is return. Just try to understand the concept of package. About this terms and terminology used in the duct, we'll discuss later. We have a separate topic for this. So got the idea online about the package, air cooled package. So why we are calling air cooled? Because the condensing unit. Now we'll talk about water cooled package. You see, in water cooled package, this side is 100% same. Means this air side, this supply duct, this side is 100% same in water cooled package. You'll find change in the condensing side. So in water cooled package, the condensing unit is cooled by water. Okay, so just we'll discuss the difference. Rest of the thing is same. Okay, so you see in water cooled package, here we'll connect the supply duct, return duct. This side is same, and this unit is placed inside the building. The air cooled package must be placed outside the building because the condenser is air cooled condenser. No? Achha, one more point. Remember, when we connect this duct, this supply duct or return duct, since this is partly inside and partly outside, na? So this duct which is outside the building, you must cover with the insulation. Even inside the building also above the false ceiling, we are using the insulation. But in some project, you will not find the insulation inside the building. But as per standard, complete duct, supply and return with insulation. If you not use the insulation, the cooling is going to lose na, in supply duct. Okay. And in return duct, it may gain the heat from outside. So unnecessary, the load on the coil will increase. Okay, and the same thing is applicable even for water cooled package also. So as I said, air cooled or water cooled package, the air side system is same. Next, so let me continue with the water cooled package. So in water cooled package, the condensing side is different, and the condensing unit is cooled by water by using a shell and tube condenser and will cool the refrigerant which is flowing in shell and tube condenser by using water. And that water we are going to cool by using a cooling tower. Okay, so try to understand only the condensing side circuit. Rest of the thing is same. So you see, this side is same as air cooled. But you see, this condenser type is different. In the previous air cooled, you will find the coil and fin type. Air cooled, that is that fan and tube condenser. But in water cooled, you will find shell and tube type condenser. And remember, shell and tube type can be a condenser or can be a evaporator. And that concept you'll find in chill water system. So shell and tube is a heat exchanger. You find different type of heat exchanger. You see, this also heat exchanger. This evaporator coil. This also heat exchanger. Na? This is a what tube and fins type. You'll find different types of heat exchanger. Can be used to reject the heat or extract the heat. Depend. Similarly, this is shell and tube heat exchanger. In water cool package, we are using this heat exchanger for condensing side. So we used to call this as shell and tube condenser. Okay, so try to understand the concept for this condenser side. Very simple. You see here the detailed view for this. When you see this pipe, if you talk about this line diagram, this pipe I can connect and this pipe I can connect here. I'll show you, but let me complete this shell and tube condenser first. Shell and tube. You see the outer one is called shell. Inside you'll find the tubes. So we used to call shell and tube. And here the water in and this say water out. H2O out and this is H2O in. And you see when the water in the shell, inside the shell you'll find the tubes. And inside the tube, you see you'll find the covering like this, refrigerant in. And here you'll find, say I'm using a pipe, say refrigerant out. So when the refrigerant in, it will flow inside the tube, not enter the in the shell, in the tube. So refrigerant in as what? Since it's a condenser, refrigerant in the hot state na, after compression. Now, when the refrigerant in hot state, we are supplying the water, not chilled water, normal atmospheric temperature water or a cold water, I can say. So when the cool water enter in the shell, it will flow over the coils, and you can find the partition. This is called baffles. So water in and it will flow like this, and water out. And water is responsible to extract the heat of refrigerant. Extracting the heat from the refrigerant, condensation happened. And at the outlet of this refrigerant in the liquid state, the process. Here we are cooling the refrigerant by using the water instead of air. What we discussed in vapor compressed cycle. If you use the air to cool the condenser, that is called air cooled system. If you use the water to cool the condenser, that system we can call as a water cooled system. So here we are talking about package. So this is water cooled package. So we are using the water to cool the refrigerant. But again, in order to use this water again, the water must reject the heat, na? Because it's a cycle, right? So what will happen? This hot water, which is from the shell, we are supplying, you see, here cold water in, hot water out. You see this out, I can write here. And this in, I can write here. So cold water in, and it will extract the heat from the refrigerant, hot water out. And this hot water we are supplying to cooling tower. In cooling tower, you'll find forced convection. What will happen in the cooling tower? The hot water which is out from this condenser, we are supplying in the cooling tower in the form of a sprinkler. I'll show you this cooling tower. Let me complete this. So at this level, just remember, when the water is supplying to the cooling tower, here in cooling tower, we are using a fan and it will suck the air from this passage. And this water, the hot water in the cooling tower, we are supplying in a sprinkler form. So what will happen? The air, this is a forced convection because you'll find the fan. The air will extract the heat from the water, evaporative cooling. Only the cool water is allowed to condense, allowed to collect at the bottom. And the hot vapor, this cooling tower is throwing off. Nothing but evaporative cooling. Like in air cooler, you'll find the evaporative cooling. Na? So the heat from the air the heat from the water, which is used to cool the condenser, is going to extract by using this cooling tower. Only the cold water is allowed to collect at the bottom, and the same water is used to supply back to the shell and tube condenser by using this pump. And this pump is, you can call as a condenser pump. Very small capacity pump because it's a package. In case of chiller, water cooled chiller, the case will be different. You'll find higher capacity. And remember, the same concept for condenser you'll find in water cooled chiller also. This will help you at the time of when we deal with the water cooled chiller. And in air cooled chiller, you'll find shell and tube evaporator. So shell and tube heat exchanger you'll find in air cooled chiller as well as in water cooled chiller for condensing side as well as for evaporative side. So this concept will help you. At this level, just I'm giving the reference. So since in this system, the condenser is used water to cool the refrigerant. So this system we can call as a water cooled system, and this system is a package. So it's a water cooled package. And remember, this unit we can place come inside the building, but this cooling tower we cannot place inside the building because this is used to separate the hot vapor from the water. So this must be placed outside the building only. Got the idea online? You see, at this level, just remember, cooling tower is used to cool the water. How exactly in detail I'll show you at the time of water cooled chiller. Just I'm holding this because again the same thing will repeat.
The cycle in between the condenser and the cooling tower will be remaining same as like in the water cooled chiller, right?
Water cooled chiller.
Yes, yes, yes. The cycle in between condensing unit and the
Yes,
cooling
yes, yes.
cooling tower is same as the
See,
water
if you
cooled
talk
chiller.
about water cooled package or water cooled chiller,
Mm.
the condensing side concept is same.
Condensing and the cooling tower cycle is same.
Yes, I'll show you with more details because it's here is a package. So I'm just explain the concept. At the time of chiller, we'll discuss with more detail because you'll find the separate cycle. Anyhow, the concept is going to be same, but I'll show you with more detail. At this level, I've not added much details in this because you see in actual practice, in Blue Star or Mitsubishi, with few makes only you'll find water cooled package. So this is not commonly in Gulf or in Western countries. You'll find in India with that with the Blue Star or with the Mitsubishi. I think Blue Star is confirmed. So this is not commonly in market. So that's the reason I have not given the detail at this level. But don't worry. When after completing water cooled chiller, you'll get clear idea about the cooling tower. Only I'm holding this.
Or any advantage or disadvantage of both the system, like
Yes. Yes. You'll find in the next page only. So any confusion in the concept of air cooled and water cooled system online? What air cooled and water cooled package? Got the concept now?
yes, yes.
Yes, sir.
Now you see, if you want, you can make a note of this point. A refrigerant.
Just 1 minute. Please continue.
First point you can write. A refrigerant is 20 times more effective than, so in extracting the heat,
Refrigerant is 20 times more
effective in extracting the heat than air. First point means if you use refrigerant to extract the heat compared to air, it offers 20 times more effectiveness. Second point, refrigerant is 10 times more effective in extracting the heat than water. One more point, water is 10 times more effective in extracting the heat than air. Now you can able to compare this air cooled and water cooled system, and the same point is applicable even for air cooled and water cooled chiller also. So remember, if you see this air cooled system is effective, don't write this, let's listen. I'll give you this point at the time of air cooled and water cooled chiller. At this level, just listen. You see, if I use air cooled condenser will provide you the best efficiency if the outside temperature below 35 degrees centigrade. If the outside temperature above 35 degrees centigrade, like 45 or 50, like in Gulf, in that case, water cooled efficiency or water cooled system efficiency is higher, because if the outside temperature is higher, if you use the air to cool the condenser, the difference of the temperature is less, na? So the efficiency of that air cooled system drops. In that case, water cooled system work efficiently with a small size capacity system. Means I'm talking about the size of the system. You can expect the higher efficiency even in air cooled, but the size of that air cooled condenser will increase. So if you want higher efficiency with compact in size, you can expect in water cooled system. This is the main point. Apart from this, we have some more points to discuss. Next, you see, We have advantages of this package and disadvantage also. Ventilation as per standard. You see, this advantage is common for air cooled and water cooled both. You can provide the ventilation in both the side because you see air side system is same na in air cooled and as well as in water cooled. Next, easily available in I'm talking about air cooled. Air cooled is easily available in all in many locations. Water cooled is limited. But if you talk about, you see, generally package means generally the people are thinking for air cooled package only. Water cooled, as I said, na just available with the few makes only, not in all, or not in all the locations also. So easily available. I'm talking about this air cooled side. Next, it's a factory assemble, so you can expect the quality. On site, we need to go for the ducting, installation of ducting side, but the refrigerant piping and all, we are not disturbing anything except this. Again, this point is related to the air cooled. In water cooled side, again, the cooling tower side, we need to go for installation. But still, in that case also, we are not disturbing the refrigerant cycle, and it can be placed on the rooftop or any open space away from the building or backyard. Rooftop means, again, I'm talking about air cooled package. We are not placing the water cooled package on the rooftop. Water cooled package we are placing inside the building, except the cooling tower. So just most of the points is related to air cooled because commonly in market you'll find air cooled package, and it will not affect to the building elevation because we are not placing on the wall on the like a split system. We are placing on the dedicated area on the roof or a separate space backside of the building. And in case of maintenance, the technician can work easily because it is not on the wall hang, and it ducts have acoustic lining to reduce the noise. Acoustic lining means inside the duct. You see this hatching double hatch represent lining, acoustic lining. It can be a nitrile rubber or it can be this fiberglass. We have a separate topic of duct insulation. Under that you'll find thermal insulation, acoustic lining, and you see double hatching represent internal lining which is used to reduce the noise. Not only for package, even for other systems for duct we require this insulation to reduce the noise. That is called acoustic lining. Because the fan motor is the higher capacity, because the fan motor is used to supply the air to the last air terminal. Okay. Next, if you talk about disadvantage, you see capacity of fan should be higher because we are placing the unit away from the conditioned space. From that point, we are interested to supply the air to the last air terminal. Okay, so the fan capacity comparing with the ductable split. In ductable split, outdoor is outside and the duct is going to start from the AHU, and AHU we can place inside the building. So the length of the duct means starting from inside the building only. So, and if the length of the duct decreases means the fan capacity, the static pressure which is used to supply the air also decreases, means the HP of the fan motor will decrease. So in case of package, since we are placing away from the conditioned space, or if you talk about air cooled package, we are placing on the outside the building. From that point to supply the air to the air terminal, so we require higher capacity, and that will increase the air side running cost. Next, as I said, the duct must be completely with insulation to reduce to avoid the energy losses. And the initial cost. The initial cost is high compared with what? Split system. I'm not compared with the chillers. Chillers different category. Different category. If you talk about split system, the cost is almost 8 to 10 times higher. Okay, not sorry, my mistake. Five. This you can consider say 4 to 5 times higher. In VRF, the case is different. You can approximately consider 4 to 5 times higher because first of all, the unit is expensive and the
As
installation
compared
cost
to
also increases compared to split. The installation cost also increases and we require separate ducting installation, ducting fabrication. So compared to split system, we can expect minimum 4 to 5 times expensive. Next, we have this VRF system, which is latest in the market. Latest means compare with other system. This also from last 10 plus years in the market. But compare with other system, this technology is a new. Okay, so in the next session, we'll continue with the VRF. Okay, which is interesting and important too as per the market requirement.